Billion years, life has thrived on planet Earth. The shape of each organism forged by multiple factors. The human body, too, has been shaped by evolutionary need into a unique form.
Things like a hammerhead shark, the neck of a giraffe. All of these things strike us as being somewhat peculiar. But you know what? That's really no more peculiar than we are. Humans do indeed have a peculiar shape, and it's quite unique. No other animal has anything even approaching it.
The focus of anatomist Bruce Latimer's work is the evolution of the human body. He believes we were shaped in large part as a result of a single behavioral change in our ancestors. They stood up.
We've been walking upright for at least, I would say, 4.5 to 5 million years. And we are a striding biped, which is to say we stand on one foot at a time. That's a very different way to get around, and as far as we know, no mammal, save ourselves and our immediate ancestors, has ever even tried to experiment with this kind of locomotion.
Latimer believes that pre-humans stood in order to free their hands so they could carry food and make it easier to nurture their young. He believes that free hands led to the development of tools, which led to cooked foods, which led to better nutrients and a larger brain. This would enable us to spread across the world, all from just standing up, a change that shaped our body, starting with the spine.
This is a female gorilla. You'll notice that that spine is essentially straight.
To accommodate the biomechanics of walking, the spine transformed over millions of years into a winding set of 4 curves.
In your lower back, no other mammal has a lumbar lordosis. The reason we did that is because we couldn't block the birth canal. In order to keep that open, we had to keep our sacrum tilted the way it is. Because of that, our head would be out in front of us, which you really couldn't walk like that, so we had to create a curve. That curve creates the hollow in our back. Now, having once accomplished that, so we can get our torso over our hips so we can balance, then we'd be leaning backward too far. So we put in another curve in the opposite direction, and then our head would be sticking out too far in the front. So in order to balance that, we put in another curve here at our neck.
A lengthened and curved spine, knees closer together than hips, a barrel chest. All of these are a result of a determined effort over 1 million years to walk, a skill that still does not come easy.
You really don't learn how to walk until you're 8 or 9 years old. And if you look at the gait of a young child, it's not like an adult. It takes you quite a while to develop those neuromuscular pathways that allow you to do this thing. Another example is that blind children will not spontaneously stand up. They have to be taught to stand up, so it is truly a learned behavior.
Scientists are still trying to understand the basics of what most of us take for granted. Since 1990, scientists and engineers in a robotics lab at the Free University of Brussels in Belgium have been trying to create a robot with human proportions that can walk freely.
Our human body is an incredible complex machine. We have over 600 muscles, and we do not completely understand how we walk and run. So therefore we can build robots with less complexity to try to understand.
The result?
We had a lot of problems and often the robot fails to work. The feet are quite small, so the robot always risks to fall over.
While man's quest to walk upright has influenced the shape of our body, some other creatures also decided to walk on 2 legs. Dinosaurs, like T-Rex, also evolved to move on 2 legs. And today, the dinosaurs' descendants, land-based birds, do the same. Capable of speeds up to 65 miles an hour, the flightless and bipedal ostrich, the fastest running bird, can outrun predators like lions on its powerful long legs. And flamingos feed in swampy waters on 2 legs, keeping their feathers dry. Among mammals, though, humans have another biped companion, the kangaroo.
Kangaroos are shaped in a really sort of a weird way. They have these big, strong hind limbs and these short little Tyrannosaurus rex-like forelimbs and a big, huge tail. And when they're moving slowly, they do something called pentapedal locomotion, where they walk on their forelimbs and their hind limbs and their tail at the same time. But then when they want to go fast, they just pick their hind limbs up and they jump, they bounce, using their tail to keep their center of balance while they jump around in the outback of Australia.
The Australian landscape is massive, and kangaroos' big feet may have evolved to help navigate it.
Kangaroos evolved about 50 million years ago from possum-like marsupials. The first kangaroo-like animals could be seen 30 million years ago, and by 25 million years ago, kangaroo evolution was well on its way.
The hopping motion depends on elastic tendons in the hind legs, so moving takes up very little energy in the kangaroo. A must for survival when you have to cross huge areas of land.
For kangaroos, it's all about just like, we're out of food, let's go for a walk. And then they go for 100 kilometers and get to a new patch of food.
The kangaroo shape has evolved to be a perfect fit with its environment. Otherwise, it would not have survived. And while bouncing may be the most efficient way for a mammal to travel on foot, it's not likely that other species will follow the kangaroo's example.
It's not like horses can look and see how kangaroos are doing and decide to start pointing their evolution in that way, get rid of the way they're running and start hopping on their hind limbs. That's not how natural selection works. To a large extent, it was probably luck that got kangaroos pre-adapted to start using that bouncing locomotion. But now that they have it, they're moving more economically than any other kind of creature.
From the outback to under the sea to the sky, every creature owes its unique shape to the powers of evolution to change over millions of years, molding limbs, heads, and shells into a form that can survive. As life on Earth moves toward its 4 billionth year, the shape of things will continue to evolve.